So let's start today's topic, and today the topic is holography. Now in 1948, D. Gabor introduced holography. Now what does it mean? The word hologram is derived from Greek word holos, and it means that complete or whole. So the whole of information is actually recorded in a hologram. As the word holo in Greek, it means the whole or complete. So hologram means the complete information. Now first of all, we should have a look at the difference between the holography and the ordinary photography. Now we all know that in a photograph or in photography, we actually record the intensity of light incident on the subject. But if you have a landscape view with a group of people standing in front of the camera, you will find that the depth of field or the perspective vision is lost in a photograph. That means that in a group of people, when they are arranged or when they are standing in a manner that no one is bothered to have a queue, that means by viewing the photograph, you cannot be able to find who is standing in front of whom and how much is the distance between the two. So that is actually a problem in photography, or in other words, the information of depth of perspective view is lost in photography, or it is actually not recorded in a photograph, as because in a photograph we actually have the intensity of light. We have recorded the intensity of light used or the intensity of light incident on the subject, and no phase or information of phase is recorded in a photograph. And here lies the difference between a photograph and a hologram. Actually, in a hologram, the entire information, as I have told you, that the Greek word holos mean the whole or the entire. So what is the entire information? Entire information means not only the intensity of light, but also the phase relationship. So in a hologram, both the intensity of light and the phase relationship are recorded. So that is the basic difference between a hologram and a photograph. Now, so what is a hologram means? Holography, the process, holography is a lensless two-step imaging process. Holography is a lensless two-step imaging process, and in which we can produce three-dimensional images. So hologram, that is also a difference between a photograph and a hologram. A photograph is a two-dimensional view, two-dimensional image. In a photograph we can find a two-dimensional image, but in a hologram we can find a three-dimensional image. So holography is a lensless process. We all know that for a photography a lens is required, but in a hologram lens is not required. It is a lensless two-step process. Here two steps are required. I will show you what are those two steps. So holography is a lensless two-step process, imaging process, and which can produce three-dimensional images. So in the year 1948, D. Gabor introduced firstly the holography or the hologram. Okay. Now here, as I have told you, that holography is a two-step process and this is one of the steps. Now the step is known as recording. It is the recording, or we can call it as the construction of a hologram. Construction of a hologram. So this is the first basic step, or this is the first step of holography. Here, as you can see, a beam of coherent light. First of all, we have to use a laser beam. We have to use a laser beam. Why a laser beam is required? As because coherency or coherent beams are required. So as we know that no other beam or no other light can produce a coherent beam. So a coherent source means laser. So I have taken a laser beam, and here a beam of coherent light from a laser is splitted into two. You can see there are two beams, and it is splitted by a semi-transparent mirror. It is the semi-transparent mirror, and this semi-transparent mirror splits the beam into two. The one beam is known as the object beam and the other beam is known as the reference beam. So a coherent, highly coherent beam from a laser source is splitted into two by a semi-transparent mirror, such that one beam called the object beam can be scattered by the object. This is the object, and the object beam, when falls onto the object, it is scattered by the object, and then the other beam, that is the phase related beam, and this is the reference beam. So the phase related reference beam, these beams or the object beam actually carries the intensity distribution, and the reference beam carries the information of the phase. So these two beams falls directly on the film, and this film actually records the hologram. These two beams form interference patterns, as these two beams are coherent beams, and these two beams, when fall onto the hologram or onto the film, it actually makes an interference pattern, and the film then contains informations regarding both the amplitude and the phase, and thus a hologram is produced. Now this step of holography is called recording or the construction of hologram. Is it okay? I am repeating once more what is the process. So there are two processes for a hologram. The first process is known as the recording of a hologram or the construction of a hologram. And in this process, actually a laser beam, a coherent laser beam, is incident on a semi-transparent mirror, which actually splits the beam into two. The first beam is the object beam and the other beam is the reference beam. Now this object beam, when scattered by an object, it actually falls onto the film, in which also the reference beam is incident, and these two beams, that is the scattered beam from the object, that is the object beam, that is the scattered object beam, and the reference beam then interferes on the film, and thus it records the entire information, that is both the amplitude or the intensity and the phase. So this is the process of recording, or this is the process of construction of a hologram, right? So let's move on to the next part, that is the reconstruction steps. That is the second part of a hologram, the next step, and it is the reconstruction step. Okay? Now let's draw the picture of reconstruction of a hologram. This is an easy topic to discuss. So now this is the process of reconstruction. Now while reconstructing the hologram, we have to use the coherent light, and that is known as the reconstruction beam. So this is the reconstruction beam. And what is the reconstruction beam? It is usually of the same wavelength as the original beam which is used while recording the hologram. So while reconstructing the image, while reconstructing the hologram, what we have to use, initially we have to illuminate that hologram by the reconstruction beam, and this reconstruction beam is usually of the same wavelength as the original beam. Here the hologram acts like a diffraction grating. It produces two sets of diffracted beams. One set forms the real image. One set forms the real image, and the other set, as you can see, it actually produces the virtual three-dimensional image. So that is the part of reconstruction or the process of reconstruction. So again I am repeating this process of reconstruction. So while reconstructing the hologram, we have to illuminate the hologram by the reconstruction beam, and this beam is actually of the same wavelength. This beam is actually usually of the same wavelength as the original beam, and here then the hologram acts like a diffraction pattern, diffraction grating, which actually produces two sets of beams. The first set produces a real image, and the other set produces a three-dimensional virtual image. So this is the process of reconstruction. So in a hologram, these two steps are required. The first step is the recording of a hologram, and the second step is the reconstruction of the hologram. Is it okay? So now I will proceed towards the mathematical analysis of the holography or the hologram. Have you any query? Have you any question about the recording or the reconstruction of a hologram? If it is okay, then I will proceed further. Is it okay? Okay, fine. So let's move on to discuss the mathematical theory. Now, as in the recording process, what we have find that that the object beam which is scattered by the object is incident on the hologram or on the film, and the reference beam, it is it okay? So, in the recording process, as I have just now explained, that after the laser beam is splitted by the semi-transparent mirror, one set of beam, that is the object beam, falls on the object, and after scattered by the object, it then falls on the film. The object beam carries the information about the intensity of light, and the other set of beam, which is the reference beam, it actually carries the relation or the information about phase. Now these two beams, that is the object beam or rather the scattered object beam and the reference beam, when falls onto the film, these two beams interfere with each other, and then it produces or it records the entire information of the amplitude and the phase of the light used in the hologram, and thus the recording process is done. So, in the mathematical analysis, we actually taken the complex amplitude of the light wave which is scattered by the object and striking the hologram or striking the film. Let it be A equals to A0 e to the power I psi. So this is the scattered ray or the ray scattered by the object. This is the object ray. This is the object ray which is actually scattered scattered by the object, object ray scattered by the object, and which actually strikes the hologram, and the equation is complex amplitude is A equals to A0 e to the power I psi. And now we have to take into account the reference wave. So let the reference wave be R equals to R0 e to the power I phi. So these are the two rays. The first one is the light wave scattered by the object and striking the hologram, and the second equation represents the reference wave. Now, as I have told that in this entire process, these two rays are coherent in nature. So that means that the phase of these two rays are correlated, and hence the resultant complex amplitude be capital R equals to small a plus small r. So that is the resultant complex amplitude. Now what will be the intensity, as it is the resultant complex amplitude? So the intensity on the hologram plane, intensity on the hologram plane will be capital I equals to capital R into the complex conjugate of R, that is R star. Now we have the value of R, that is A plus small r. So the complex conjugate of R, that is R star, will be A star plus R star. So after making the product or the expanded form, that will be A star plus R star plus R star plus R A star or A star R. Now this A star and R star can be written as A0 square plus R0 square, and then these two, it will be twice A0 R0 cos of phi minus psi. Let it be equation number 1. So this is the intensity on the hologram plane. Here we can find that the resultant intensity is the sum of two intensities. The sum of two intensities, that is A0 square plus R0 square. These are the sum of two intensities, and the interference term contains relative phase information. So this is the relative phase information lies here. So in the intensity on the hologram plane, the resultant intensity thus carries both the intensity distribution as well as the phase relationship, because here the sum of two intensities are given A0 square plus R0 square, and the interference term contains relative phase information. Now, by a suitable development process, the amplitude transmittance of the hologram is adjusted to be proportional to capital I. Now, if the original reference beam, so this is the part which actually is used while recording. So this is the mathematical analysis of the recording of beam. And if it is okay, then I will proceed further towards the reconstruction or the mathematical analysis of the reconstruction of beam, of hologram. Is it okay? I think it is very much simpler mathematical calculations are required for the holography as a whole. Here you can find only two beams. First one is the object ray scattered by the object, and the complex amplitude is taken as A equals to A0 e to the power I psi, where psi is the phase. And then the reference beam has been taken as R equals to R0 e to the power I phi, as because these two rays are correlated in terms of phase, that means they are coherent in nature. So that means the resultant complex amplitude will carry capital R equals to small a plus small r. And if the amplitude is given, then intensity can be found by the squaring of the amplitude. Now here R into R star is the complex conjugate of capital R, and then I have put it the values, and then after all A star means A0 square, R star means R0 square, and this is twice A0 R0 cos phi minus psi. So in this equation number 1, what we can find? We find that there are sum of two amplitude square, or the sum of two intensities, and the interference term contains the relative phase information. So that is the vision, that is the essence of holography, what I am trying to tell you, that in a holography both the intensity as well as the phase relationships are recorded. So this is the mathematical analysis behind the recording of the hologram, right? Okay, now let's move on to reconstruction of the hologram. Now, as we know that for the reconstruction process, a reconstruction wave is required. And what is the reconstruction wave? The reconstruction wave is nothing but a wave which is actually of same wavelength as the original beam. So here the reconstruction process. So now I am taking the original reference beam. The original reference beam here is used to illuminate the hologram. So the reference beam, as I have taken the reference wave as R equals to R0 e to the power I phi. So this is the reference wave which is used to illuminate the hologram while reconstruction or while reconstructing the hologram. So the original reference beam is used. Then the complex amplitude of light just after passing the hologram. So the complex amplitude of light. So now here the reference wave is used. So let's wipe out this equation. Just leave this reference wave as because it is now used for the reconstruction process. And if the original reference beam is used to illuminate the hologram, then the complex amplitude of light just after passing the hologram is capital A, that equals to K into small r into capital I. Okay, now here K is nothing but it is a constant of proportionality. So putting the value of R and then I is given in equation number 1, which I am just now wiped out. So the product will be R into I, that means R0 square into A plus R plus A0 square R0 e to the power I phi plus A star R0 square e to the power twice I phi. It is equation number 2. So now I am making the product of small r into the intensity, as because why I have taken capital I as because now I am illuminating the hologram, and in the hologram the entire recording process is done. That means equation number 1 is embedded in the hologram. So while reconstruction process, when I am illuminating this hologram by the reference beam, original reference beam, what happens that R into I will be there, and as R is given by R0 e to the power I phi, so that means it will be A0 square R0 e to the power I phi plus R0 square, and then R0 square A star e to the power 2I phi and R0 square into A plus R. Now in this equation number 2, the first term on the right hand side, that is R0 square into A plus R, this is this term. So the first term of equation 2 represents a wavefront whose complex amplitude is proportional to that of the original wave amplitude, that is A plus R. So this actually gives rise to the three-dimensional virtual image. So this particular term, that is R0 square into A plus R, it actually generates that three-dimensional virtual image. Okay? Now, if the reference wave is strong, that is A0 square by R0 square, very less than 1, if the reference beam is strong enough, then the second term can be neglected, that is A0 square R0 e to the power I phi. This term can be neglected, and for a reference wave whose phase and amplitude are almost constant all over the hologram, the third term is proportional to the conjugate of the object wave amplitude. The third term that is A star R0 square e to the power 2I phi, it is actually proportional to the conjugate of the object wave amplitude, and this generates the real image. So this term generates the three-dimensional virtual image. This term generates the three-dimensional virtual image, and this term, that is the third term, it is responsible for the real image. And if the reference beam is strong enough, if the reference wave is strong, then the second term can be neglected. So this term can be neglected, and these two represents the virtual image, that is the three-dimensional virtual image, and the other one is the real image part. Okay, so this is the all about, sir, I equal to square A here. I can get it, Shilpa. I equals to square A here. I equal to square A. No, I is actually the equation number 1 itself. I have written capital I equals to, in equation number 1 it was A0 square plus R0 square plus twice A0 R0. You can find it as A star plus RR star plus AR star plus A star R. It can also be taken, and then just make the product of R with the values of I given in equation number 1. Okay. Now at the last part of this lecture, as because the construction and reconstruction is done, so now we have to talk about the application of holography. Where does it finds application? Now holography actually what we found that holography gives a three-dimensional idea of the object. It gives the three-dimensional idea of the object. Okay, so a single hologram can record a large number of images, and this is also another important difference between a photography and holography, that a single hologram can record a large number of images. And another aspect of hologram is this, that a small portion of the hologram can reproduce the entire image. So whenever while retrieving the data, today we have found a old photograph of our ancestor, and if we have to reproduce the original picture from the picture found, and it is torn, it is gray in color, so that actually requires a lot of editing, and then we can find a image of our ancestor from that particular picture. But if a small portion of picture is found, then we cannot produce the original photograph from that particular part of the portion of the picture. But here lies the difference. If a small portion of hologram is found, then we can reconstruct the original hologram from that particular portion of a hologram. And these properties actually make holography very popular in many applications. We have found holograms in our books. We have found hologram in many objects what we use in our everyday life. So holography and most common applications are in holographic microscopy, holographic interferometry, 3D cinema, non-destructive testing, etc. These are the applications of holography. But remember that holography or a hologram actually carries a large value or huge information what we cannot be stored inside a photograph in a photographic film. And the important aspect of holography is that what I am just now tell you, that if a portion of hologram is found, then the entire image can be reconstructed from that particular small portion of a hologram. So this is all about holography. In your syllabus, you can find that there are construction or recording and reconstruction of holography, and then this is entirely all about the syllabus of holography. Okay, so goodbye.